I'm back, and here is the periodic table of elements that you might recognize from the front of most science laboratories. And the goal is to be able to read the periodic table and to understand why are the elements located in certain positions in the periodic table. Because after all, you might think, why does this periodic table, why does it stick up on the sides? And then why has it got this stair thing? And then what's that stuff there that's at the bottom of it? Why not just make one big rectangle that has all of the elements in it? Well, it's very important that the periodic table is shaped the way it is, because that tells chemists about the reactivity of certain elements. All right, first you need to know about the atomic number and the number of protons inside of a particular element. So you will notice that if you look at this chart, and remember that you can download this off the internet, or you can blow up the picture so that you can see this in more detail. But you will notice that every element in the periodic table has two numbers. One of the numbers does not have a decimal point, and then one of the numbers does have a decimal point. Now, we don't care, at least not yet, about any of the numbers that have the decimal point. So we're only concerned about the numbers on the periodic table that don't have the decimal point. And so what that's going to be is the atomic number, and that is going to be the number of protons in its nucleus. So, for example, helium is given by the letters He, and if you look at it on this chart here, you will notice that helium, which is located on this side of the chart and it's all the way up at the top, has a 2 for its atomic number. And so that means that it is going to have 2 protons in its nucleus. The number of protons determines the element. So if you look at this chart, every known hydrogen atom in the entire universe has 1 proton. Every helium in the known universe has 2 protons. Every lithium in the known universe has 3 protons. So it's the atomic number that is going to determine the identity of the element. If you start messing with the number of protons in the nucleus, you change the identity of the element. Sounds like a test question, doesn't it? And you notice that helium also has this other number that has a decimal point. That's going to be called the atomic mass, and we're not interested in that, at least not yet. Okay, now another thing that we could do, though, is that we could knock electrons off. So most atoms are going to be electrically neutral. So let's go back to helium, for example. So helium is going to have 2 protons in its nucleus, and then it's going to have some neutrons in there as well, but let's not worry about them. And then it's going to have 2 electrons in orbit around it. And again, this is the classical picture showing what those electrons are doing, but this isn't quite right, but just bear with me. It's got 2 protons, so that means it has a +2 charge in the nucleus, and so that means we need to have 2 negative electrons to cancel it out. So if on the exam I was to say how many total electrons does carbon have, okay? So what you would do is you would find carbon, which is the letter C on the periodic table, and you would find its atomic number, which is 6. And so therefore, it's going to have 6 electrons. So the atomic number not only tells you the number of protons, but it also tells you the number of electrons if it's electrically neutral. But notice that I could take an atom and I could hit it with my hammer, or I could hit it with electricity, or I could hit it with light, or I could hit it with heat. And what could happen is one of these electrons could go flying off, carrying away its negative charge. So what would that leave you with? So you would still have two positives and you'd have one negative. So then what we would say is that this would be helium, He, but now it's going to be a plus helium, and we have ionized it. So an ion is going to be an atom that is either missing electrons, it could be more than just one, it could be missing more than one, or it could be an atom that has too many electrons. So what would we call it, for example, if we put a third electron? So now there's 3 electrons in orbit around this thing. So then you would have 1, 2, 3 negative charges, but inside it's 2 positives. So then we would call this one a helium negative, and again it would be an ion. So we have ionized the atom. So be able to do this on the exam. If I was to give you an element, and I'll just make up something. So let's say that it's iron, and then I'm going to put -2 on there, and I could say, what's going on with this iron? And then you would say that it has 2 extra electrons in orbit around it to give it that -2 thing. All right, let's take a break. When we come back, we're going to talk about where do the electrons live inside an atom.